Hey guys, Mrs. Traver here. We're going to walk through notes on functions, and this time we're going to look at them with the domain and range. So we started some vocab yesterday, and we defined for ourselves what a function is as a relationship that is only going from each x to one y. And now we're going to look a little bit more at the input and output and look at some different definitions. So the input output, we talked about these yesterday. Input are like the x's and outputs are like the y's. The new name that we're going to have for these guys, well, let me write the x's and y's down. So those are related. We also have the new word that's coming into play here, domain and range. So domain is the set of all points that the function hits in the x-axis, and the range is a set of all points that the function hits in the y-axis. So we'll be able to look at what the domain and range is of each function. The other thing to note too is because the input is what you put inside of it, it is the independent variable. So this variable is independent. So I kind of think of this like as if I was cooking. I can put anything into my oven, but what comes out of my oven is dependent on what I put into it. So if I put in some cake batter, I'm going to get out a cake. I'm not going to get out a cake if I put something other than cake batter in. So what I put into my oven is independent of anything else, and what comes out depends on what was put in. So that makes our y variable the dependent variable. So all of these words go together is what I want you to be aware of, because sometimes at assessments and on tests and that kind of thing, these words are used interchangeably, and we need to be fluent in being able to switch back and forth between those guys. So let's look at finding the domain and range. There are going to be some questions like that you come up with. So we're going to work on finding the domain and range a few different ways. The first way is if we are given points. So say I was given this set of points, and I was asked to find the domain and range. So what I can say is that the domain is the set of points that was input. So those are all of my x's. So I can just list those. I've got -4, -3, 0, and 2. My range, on the other hand, is all of my output. So it's the set of points that came from the y's, my 2, my 1, my 2, my 1. But I don't need to repeat those each time. So let's just say it's the points 2 and 1. Those are the only things that were in my range. So the big deal here is that a domain isn't going to have any repeats. It shouldn't. Otherwise, it's not a function in the first place. Speaking back to last time's notes. But in the range, don't write the repeats. Otherwise, that looks weird. So remember when we did set notation, we talked about this too. It's kind of like when we did sets with the unions and the intersections. So that's finding domain and range when you're given a list of points. If you're given a function, given a function and a domain, and you're trying to find the range, let's try that. So in this one, we were given this function y equals -3x plus 5, and we want to find the range that goes with these domain. So the way I would think of it is, since the domain is a set of x's, is saying, well, in this situation, if x was -2, what's y? So the range that goes with this is, let's plug in this -2 into our x spot and think through that. I'd have -3 times -2 is +6. 6 plus 5 is 11. If I plugged in a -1, I've got -3 times -1 is 3. 3 plus 5 is 8. If I plug in a 0, -3 times 0 is 0. This goes away, and I've got 5. And lastly, if I plug in a 1, -3 times 1 is -3. -3 plus 5 is 2. So to find the range given a domain, you just have to plug each of these guys in for the x. The mistake I see is that you're plugging it in for the y on accident. So there's those. The last thing I want to talk about in this section other than domain and range is what function notation looks like. So say I were given a function like this, y equals 6x minus 4. I know that it is a function because I only have two variables at most, and both of those have exponents that are 1. There's no exponents higher than 1. There's also no variables in the denominator, so this is a plain old function. This is in standard notation. If I was going to write this in function notation, the way it looks is like this. F of x is how we read it. So this piece, it's read f of x. Please don't say f parentheses x or f times x. This is saying the function, when you plug an x in, is 6x minus 4. So it's kind of useful because then I can say, well, what if x is negative 2, for example? So sometimes we're given a function in function notation like this, and they say find f of negative 2, for example. What they're really saying is if the domain is negative 2, what's the range in that case? So instead of there being an x in that spot, I'm going to put a negative 2 in that spot. So f of negative 2 is 6 times negative 2 minus 4. So I changed out this x for a negative 2, and every x to follow changed to a negative 2. You can solve from there. Negative 12 minus 4 is negative 16. So I've got f of negative 2 is negative 16. So what I really have is that if x is negative 2, then y is negative 16. And you end up having a point with the domain and the range right there for you. All right, let's do one more like that. All right, let's do this one. F of x equals x squared plus 15. Find f of negative 2. So let's see. I want to plug in a negative 2 here and to every other spot. And here's an important plug on every time you substitute in a number, especially when it's a negative, you need to put it in parentheses. It is very important here that you do the parentheses quantity squared, not just writing it as negative 2 squared. So please write it like this, because when I do it this way, the correct way, this means negative 2 times negative 2, that's positive 4. If I do it this way, this is negative 2 times 2, which is negative 4. So you get two different answers. These are not the same thing. Be wary of that mistake. I see that very, very, very often. So please use the parentheses when you substitute. From here, we're almost done. We simplify and we get 19 out. So f of negative 2 is 19. So I know in this function, I have a point at the x coordinate negative 2, the y coordinate 19. So negative 2, 19. All right, we're going to call it quits on these notes. I hope that domain and range look good to you, because that is the main thing that I want you to have here, is that if you're given a list of points, the domain is all the x coordinates and the range is all the y coordinates. If you're given a function with a domain, you can find the range by plugging in your domain into the x spots. And then the little tag on function notation that instead of y, we could also write f of x. Hopefully this looks good. I will see you next time.